Hi, in this presentation I would like to present the service unit Terminological Services, or SU-TermServ of the German Medical Informatics Initiative and the Network University Medicine. My name is Joshua Wiedekopf and I'm a researcher at our site in Lübeck. If you have any questions about this presentation or the SU-TermServ in general, please reach out to us. Our website is at mri-termserv.de and you can reach us via email at team@mail.mri-termserv.de. This presentation is a recording of our onboarding sessions, which we currently offer regularly. More information, including the slide deck, is also available on our website. First, I will introduce the team and the project, then I will move into the fire terminology module and the services defined therein. I will give some details about the technical implementation that we have set up. Then I will introduce some administrative details and I will conclude with some literature recommendations. The SU-TermServ project originated from prior work in the HIME consortium, but picked up a lot of steam beginning in 2023 with the consolidation and extension phase of the MRI. In the framework of the MRI's grant, it is an infrastructural to-be project, which all have the common goal of advancing the harmonization of health data. The SU-TermServ has 3 partner sites: the University of Lübeck, the University of Cologne, and the Hanover Medical School. Our overarching goal is to provide and support central terminology services to the data integration centers and to the MRI and the NUM in general, in order to support semantic interoperability. We have 3 main addressee groups in our work. First, we support the designers of the core dataset while working on the CDS. We have the data integration centers by providing a reference server for the terminology used in this large project. And we work with parties like the FTPG to support their generation of search ontology and other stuff, to provide windows for researchers into the federated infrastructure the networks have stood up. The main aim of our project is to further semantic interoperability in the connected infrastructure of the MRI and the NUM. In these projects, there is already broad alignment towards utilizing syntactic standards like HS7-FHIR so that the data is stored in the same places. That doesn't automatically make the data interoperable though. Coded data in these elements is generally captured in local coding systems, if there hasn't already been a pressing need for standardized codings. A common example are laboratory order codes, which are generally speaking defined within the hospital or hospital networks. In research, case report forms often have coded data, but most of the time the answers are defined in project-specific data dictionaries. There's obviously a lot of possible improvement here. All in all, using standard terminology, or other terminologies, is one of the most pressing challenges for achieving this semantic interoperability, and only semantically interoperable data is usable by others. We believe that terminology services are an important piece in the infrastructural puzzle to achieve this, at least within defined contexts and use cases. They should not be understood as a cure-all, but without them, this whole job becomes a lot harder still. I would like to stress that terminology services are more than just the terminology server that provides them. Comprehensive terminology services cannot be delivered without the people supporting the server through their know-how, and the best terminology server is utterly worthless if there isn't the right content on the server. It is kind of hard to consistently speak about terminological artifacts in a presentation like this. There are many different terms for these kinds of artifacts, and each identifies broadly different things. Strictly speaking, for example, ICD-10 is not a terminology, but rather a classification defined mainly for statistical purposes. To keep things simple, we will call all of this terminologies anyways. There are many terminologies in use within Germany already. Some are required by law, many classifications, for example the ICD-10 German modification and the version of the WHO for morbidity and mortality coding, or OPS for procedures. Some have become ever more important in recent years, especially author codes for rare disease coding. SOMET-CT also has become more well known in the past years, with good reason as it is a very rich terminology with well-defined relationships. LOINC and EUCOM are extremely useful in the lab for communicating measurements. Pharmaceutical codes have proven to be a difficult topic in Germany, but change is on the horizon as I'm recording this. And of course, there are smaller resources that are already used in data exchange, like those in the core HS7 standard. Lastly, I would like to highlight the large number of internal artifacts, which are often called catalogs. Now let's get a bit more technical. I'll introduce the fire terminology module with the resources defined in it, and then move over towards interacting with fire terminology servers. The FHIR standard defines this terminology module as a very important part of the specification. It is quite simple in conception, but nevertheless very powerful. It is based on 4 resource types, namely code system, value set, concept map, and naming system, but the last one is not quite as important. The module has far-reaching implications for the entirety of the FHIR model. On the one hand, these resources and data types are used in other knowledge artifacts to express the profiles and so on themselves, or to bind data elements to suitable code lists, and in instance resources like a patient resource, it is used to then express the actual coded data, like the patient's administrative gender. Let's look at the graphic in more detail. It is extremely important in understanding the FHIR terminology module. First, the code system resource defines sets of concepts with a coherent meaning. In a code system, each concept is assigned a code, generally a display string, and often a number of properties, including the hierarchy between concepts. Next, the green value set picks sets of codes that are used in a particular context. A value set can draw from more than one code system and can even reference other value sets. The violet concept map is used for defining mappings from one code system to another, but notice how the arrows are drawn towards the value set. That's by design. Concept mappings are highly context dependent, so each mapping is only valid within the scope defined by appropriate value sets. On the right in salmon color, you will find element definitions, that is, profiles and other structure definition resources. Those are bound towards a value set. Sometimes this can be a value set that contains an entire code system, but a lot of the time this would only be a defined subset. And lastly, on the bottom, FHIR instances like our patient resource will reference the precise code system and code pair that the coded data is then actually coded in. There are a number of commonalities to these knowledge artifacts in terms of the FHIR representation. Most importantly, each resource is identified by a so-called canonical URI. This identifier needs to be globally unique, so that the definition based on URIs makes a lot of sense. Each organization can administer their own namespaces, so that collisions should not occur. This URI should generally be a resolvable URI, but that is not enforced. To be compatible with other systems, other identifiers like object identifiers or OIDs are also assignable to these resources. That's also where the naming system resource comes in. One important point that I would like to stress is that in the FHIR model, codes are only ever defined within a code system and can't really stand alone. Consider this example, C04. What does this code signify? It could be a code from ICD-10 German modification or the WHO version. C04 is also a topography code in ICD-03. It could also be an ATC code for the group of diuretics, which of course has nothing at all to do with the malignant neoplasms in the ICD. It could also be something else entirely, and thus can't be interpreted if the canonical URI is missing. The first resource, the code system, declares and defines code systems, which are lists of concepts with assigned codes, displays, relationships between the concepts, and other properties. All codes are unique within a code system, but concepts only exist within the code system that defines them. Since different kinds of terminology use different interpretations for code system hierarchy, there are a number of ways to interpret the parent-child relationships. And sometimes FHIR code systems don't contain the concept they define. Importantly, this is the case for SNOMED-CT and LOINC, since the representation of these systems in FHIR would lead to very large resources to make comprehensive and performant implementations possible. And some mechanisms these terminologies use are not representable in FHIR at all. Next up, the value set is used to define sets of codes, which are then bound in specific use cases. There are two aspects to a value set. First, they are defined. This definition can either be very explicit or extensional by just listing codes in a rather long list, or it can be intentional by stating rules for concept inclusion. Also, it's possible to combine inclusion and exclusion statements, which obviously is used more in intentionally defined resources. For intentional value sets, the expansion of the resource is dependent on the underlying code system or plural code systems. To avoid these changing expansions, the version of the include can be stated explicitly. Otherwise, the most current version of each code system is used. Lastly, a concept map maps codes between code systems, but always in the scope of a value set. A common example why the scope is extremely important are mappings between classifications like the ICD-10 and terminologies like SNOMED-CT. Depending on the use context, the mapping can be very different. Billing purposes might require more granular codes or have more than one target, while research into comorbidities, for example, may require more aggregation. In all concept map elements, the relationship or equivalence between the source concept and each target concept needs to be stated. There are large differences between the FHIR versions R4 and R5, but as I'm recording this in early 2025, the MII and the NUM use R4. Not always, there is a need for all concepts that a code system defines to be available. For example, there aren't a lot of use cases where users should be able to both code disorder codes and pharmaceutical products and situations leading to healthcare encounters and so on in the same field using SNOMED-CT. Thus, value sets are needed. There are different binding strengths. Required bindings cannot be overridden by broader definitions, but can be subsetted. Extensible bindings express a clear preference for the usage of a certain value set, and select concepts can be supplemented as needed. Preferred bindings only encourage the use of a value set, and the binding can be changed if required, but this is not as strong a preference as extensible bindings. And lastly, example bindings are merely illustrations of how a binding could look like, if it doesn't make sense by the core standard to define an encouraged value set. Example bindings are generally not used in downstream profiles, but are frequent in the core standard. And to actually use the coded data in FHIR instances, there are some data types. Codings and codable concepts are the most important here, and a coding is generally encountered within a codable concept. Codable concepts can contain multiple codings, and the standard requires that those codings essentially represent the same fact. For example, in condition, there could be an ICD-10-GM code for another disease of the inner ear, and another coding for an author code for the rare disease the patient is actually suffering from, which could be the semicircular canal dehiscence syndrome. Again, looking at a resource like condition, you won't be able to tell from which value set a specific coding was chosen from. That's the responsibility of the underlying structure definition, generally the profile. Okay, now let's move over to a brief tutorial on how to interact with the FHIR terminology server. The FHIR terminology module also defines operations to interact with the server that hosts the terminological artifacts. A FHIR terminology server is a FHIR server, so the normal create, read, update, delete or CRUD operations and FHIR search to find resources are generally supported. But that's much less interesting compared to the specialized operations that are geared towards the terminological use case. All of these operations are available using HTTP requests and can be invoked with GET or POST. The standard defines the operations in terms of the relative URLs they are provided from, and in terms of input and output parameters. Parameters can be required or optional, and they also have defined data types. For a code system, the server can retrieve information about a concept, relate to concepts using their parent-child relationships, and validate the existence of a code within a code system. Find matches is not a mature operation yet, but can be used to find concepts that have specific properties. Value set operations are defined for validating that a concept is a member of a value set, and for intentionally defined value sets, especially the expansion, which is the list of all contained concepts, can be evaluated. $expand is also the operation used for search. For the concept map, the main operation is the translate operation, which takes in the source concept and retrieves the respective mappings. $closure is a very specialized operation. The operations are defined either using HTTP GET or POST operations. Also, most operations are defined both on the resource level and on the instance level, but we always recommend against using the instance level operations, since those codes depend on the FHIR ID of the resources, and that ID will change when we do updates on the terminology. I will only demonstrate the resource level operations because of this. For GET operations, the parameters are provided as query parameters, shown here in orange. Some parameters are kind of hard to express in that way. For example, the search expression on this slide is hard to express if the respective value set has not already been defined and made available to the server. But since value set $expand also defines a parameter called value set, you can just provide the value set definition in line, and the server will then evaluate that parameter, apply the string filter, and return the respective list of concepts from the ICD-10-GM. Let's now look at the operations in more detail. Code system /$lookup is used to retrieve information, that is, additional properties for a concept. You need to identify the concept, which in FHIR is of course done using the code system pair, and a version could also be provided. The server will reply with a parameters resource that is actually the same for all terminology operations. All parameters will be defined in the file standard in the respective operation definition resource. In the case of $lookup, you could be interested in the display string or the properties also defined for this resource. Code system /$subsums is used to query the relationship between two concepts. There are 4 different answers: equivalent, not subsumed, and subsumes and subsumed by. Of course, you also need to identify the concepts appropriately, but since subsumption in Fire only works within the same code system, you only need to provide the system URI once. Code system /$validate code is quite straightforward, but very important. You put in the code system pair again and get either a positive parameters result or negative operation outcome, as in this case. Value set /$validate code is of course very similar to the code system operation. But since a value set can include multiple code systems, you need to specify the system of the concept as well. Versioning is a bit more tricky here, since both the value set and the code system can be versioned independently, so there is an additional parameter, system version. As mentioned before, value set expand is used for value set expansion, but can also be used for concept search. That is done in Fire since if a user is searching for a code, there should always be a clear use case in which they are searching. Context is represented by value set and value set bindings, so search within $expand makes a lot of sense. As shown previously, it's also possible to dynamically provide a value set to the server that will be evaluated instead of a predefined one, so that very complex search expressions are possible. The same caveat about code system versioning applies here as well. And lastly, the main reason for a concept map resource to exist is of course the code translation. You put in the URL of the concept map, which is actually not strictly a required parameter. If you leave it out, the server will return all mappings it knows about from all applicable maps. The same applies for the target URL. Most of the time you do want both, however. The result is once again a parameters resource, this time with parts. How to interpret the results is pretty well explained for all operations in this specification, so your clients will be able to interpret the results reliably. Okay, so now I want to briefly talk about the server we have actually deployed in the SU-TermServ project. I will keep this brief. Our server is hosted in the secure infrastructure of the Data Integration Center in Cologne. It is deployed at ontoserver.mi-termserv.de, and if you go there, you will be redirected to the launch page. There are a number of links available at that page, and we keep that updated to point at useful services and so on. We enforce read-only access. If you need resources uploaded, that will need to go through us. Our contract with CSIRO, who develop OntoServer, also requires that access is only possible to entities in Germany. We use mutual TLS for that, either via the certificates the German Research Network or Deutsches Forschungsnetz provides, or via an internal public key infrastructure. Up-to-date information is available on our website as well. Besides the Fire API, our OntoServer installation also provides a syndication feed. Syndication is a protocol that can federate resources to downstream servers. It was originally developed for the Australian Healthcare Network by CSIRO, but is being standardized as part of Fire. This protocol allows admins of local terminology servers to constrain upstream sources as a source of truth to make the resources locally available. While the distribution of SNOMED-CT and LOINC of OntoServer syndication feed is unfortunately OntoServer specific, syndication is an open standard and it's possible to implement other syndication clients. While we can't provide instances of OntoServer to our clients through the SU-TermServ project, we obviously have a lot of experience in working with the system. If you decide to acquire OntoServer yourselves, you will find some pointers on our website. For the certificates, most partner institutions will be able to acquire suitable certificates through their institution. We support the current changes of the DFN and accept both personal certificates and service certificates. If you can't acquire a certificate, we can also issue you one from our fallback PKI. After you have acquired a suitable certificate, you need to provide it to your operating system or your client to access the instance. And if using syndication, you also need to configure OntoServer appropriately. As I am recording this in 2025, The SU-TermServ has provided comprehensive terminology services using OntoServer for the use within the Medical Informatics Initiative and Network University Medicine. We host all resources that the MII, through its core dataset, provides, and with continuous updates. Our distribution model has changed to a package-based approach, which I explain in a separate talk on this channel. If resources aren't available in FHIR yet, we need to convert them to the FHIR format, and for this, we provide a powerful tool to the community. And we love to support our users through their experience in both the FHIR terminology standard and also in the use of SNOMED-CT in particular. Of course, there's always stuff on our roadmap. As of early 2025, we are working on providing a facility for the data integration centers for terminology validation. And if we sense the opportunity for new tooling, we like to provide that as well. Reaching the end of this talk now, a brief note on getting access to the server. We require that partner institutions provide a written agreement that they abide by our rules. Most importantly, we do not allow the use of our server for production purposes without a prior agreement. That means in particular that it must not be used for the validation of generated resources in your production ETL jobs. And if you need resources on the server, we will not grant write access. There is a workflow, however, for getting resources on the server that you need to follow. The agreement is available on our website. If you need to communicate with us, we have a mailing list that all project staff is subscribed to. A member will get back to you as soon as possible. We also have a Zulip stream in the MRI Zulip channel, where you can publicly discuss your questions or concerns. And our website is our default communication stream. Lastly, since this whole area of terminology and terminology servers has a lot of complexity that you may have been unfamiliar with, we want to close with some literature recommendations. The FHIR documentation is of course extremely important. Especially the terminology module is a must-read part of the specification for everyone working with FHIR. Similarly, the resource definitions need to be understood. I can also recommend the book by Tim Benson and Graham Grieve, Principles of Health Interoperability, in its 4th edition. Regarding SNOMED-CT, the foundation course can be attended without a fee via the national license. The BfArM, who are responsible for the National Release Center of SNOMED-CT, also regularly organize courses and workshops. From our team, Josef Ingenerv and Cora Drenkan have published a comprehensive book about SNOMED-CT in 2024 in German, which explains almost anything you might want to know about SNOMED-CT. And lastly, both for SNOMED-CT and LOINC, there are comprehensive resources on both terminologies in their respective portals. Thank you very much for watching this presentation. We are continuously looking to provide more material to the community and upload more videos to this channel. If you want to get in touch, please reach out via email. We are always happy to support the community. More information, including this slide deck, is also available on our website.